In this video, we'll explore H.264 encoding and decoding, all made possible by a single Matrox Mira IPX 4K capture and IP encode decode card. Because H.264 both encodes and decodes content, it is referred to as a codec, an algorithm which packages and unpackages content for further streaming or recording. Encoding is another term for compression, which reduces the size of a file, making it easier to transmit over a distance and/or to be disseminated to multiple endpoints or nodes as part of a network. Decoding, on the other hand, reverses this process and decompresses the content. H.264 is just one of many codecs designed to package together content for the purpose of streaming or recording. Also known as MPEG-4 AVC, it is the most universally deployed codec in use today. As a result of this, H.264 is the optimal codec choice right now. Different levels of H.264 encoding and decoding are available, with the highest level being 5.2. H.264 predicts the makeup of frames comprising the content, assessing information or areas that require more or less compression. For example, during a video of a press conference, a relatively stationary subject stands between a podium and a backdrop, both of which are even more static. H.264 deduces which areas will not change from frame to frame and acts to compress accordingly. It does this more efficiently than other codecs would in its place. H.264 effectively balances a tightrope between visual quality and file size for cost-effective bitrate management. As a result, bandwidth consumption is reduced when distributing and recording content, and the amount of space when storing it. As a result, it all costs less. Bitrate is defined as the amount of data encoded per second. The higher the bitrate, the higher the quality of the video. Because more data is transmitted at a higher bitrate, it also means a higher cost as well. For example, take two videos that are showing exactly the same content. One has a resolution of 1080p, and the other is a larger 4K video. Both can be streamed at the same bitrate. However, the 4K content will require more compression to accomplish this and look worse as a result. In order to maintain the same quality for the 4K video, the bitrate will have to increase. Similarly, image quality shares an inverse relationship with frame rate. The higher the frame rate, the more data there is to encode, with a 60 Hz video possessing twice the number of frames per second as a 30 Hz clip. When there are more frames, there is more data to encode. For example, in high-frequency content like live sports, higher frame rates are required for the video to be watchable, and in turn, higher bit rates are needed to transmit this video. Meanwhile, bitrate control can be described as either constant or variable. Bitrates can either maintain a constant flow of data for consistent quality, or have the codec determine how much compression is needed for each frame for greater efficiency. Remember the example of the press conference? Imagine that as one scene in a longer video, and one which could employ a fair amount of compression. In contrast, a car chase scene with multiple camera angles and constantly changing motion would involve far more unique frames and therefore be less able to employ compression. The highly efficient H.264 codec is, in part, what separates Matrox Mira IPX cards from the competition. Able to record and stream high-quality H.264 encoded video to any device with H.264 decoding capabilities over IP at low bit rates, Mira IPX creates network-enabled video walls with a single add-in card. To learn more about Mira IPX's features and how they relate to H.264, view the second part of this video or visit matrox.com/graphics/Mira IPX.